Alright guys, so now we're going to find all the roots of this one. So, Nelly, how many roots do we have? We got 3 because it's a degree. And Oscar, which numbers are we going to look at to find the possible rational roots? 1 and -6. Okay. What numbers multiply to give you -6? 1 and 6, and then 2 and 3. And what numbers multiply to give you 1? That's just 1, right? So this one's going to be kind of nice. We're just going to have that plus or minus 1, 2, 3, and 6. And it's divided by 1, which dividing by 1 doesn't change the value. Now, how many numbers do we have up there? How many suspects do we have? 4, but it's plus or minus, so it's 8. We know 3 of them are going to be x-intercepts, so we need to find at least one of them, that is, okay? So, Ruby, which number should we plug in? You can choose. Doesn't matter. We just need to choose one of our suspects, and let's test it using the remainder theorem. Let's try 2. So now for step 2 here, I'm going to use the remainder theorem. And we're going to plug in 2. And let's see what happens when we plug in 2. 2 cubed is 8. -7 times 2 is -14. Minus 6 is going to be -6. That's going to be 8 minus 20, which is -12. Nope. We didn't get 0, so what does that tell you about 2? Not a root. We don't like it. Alright, so let's try another one. That just takes one of our suspects away. What's another number we could try? We could try 1. Let me try 1 first. Because it doesn't work. You get 1 minus 7 minus 6, which is -13 plus 1, also -12. Nope. Does -2 work?
Yes.
Let's try it. So now we're testing -2. -2 times -2 times -2 is -8. -7 times -2 is 14. And we have a -6. Now, I like to combine all the positives and negatives, so if I combine -8 and -6, I get 14 minus 14, which is 0. Yes. What does that tell us about -2?
It's 0.
It's a root or a 0 or an x-intercept. They all kind of mean the same thing in this instance. And then if I wanted to put that into parentheses, I have to do the opposite. So what would go inside the parentheses? X, not -2, plus 2. This is a factor of f of x. Nice. Okay, so what we have, guys, we went through step 1. We found all our suspects. Number 2, we tested until we got one that's guilty. That takes us to step 3, which is what? Let's divide f of x by our factor so we can find the other one. So I'm going to step 3. I'm going to take f of x and divide it by x plus 2 using synthetic division. Now, I'm going to do this wrong, so don't copy down what I'm about to do, okay? If I were doing synthetic division here, I'd say, well, my root is -2. And then I'm going to look at my coefficients. I've got 1, -7, and -6. I'm going to go through my steps, bring down the 1. -2 times 1 is -2. This adds to -9. -2 times -9 is 18, and that adds to 12. Wait a minute. We should have gotten 0. So what mistake did I make that probably you guys would have made?
Put the 0.
What was that, Mindy?
You put the 0 for the x squared.
Alright, you guys remember that was synthetic division? You have to make sure that you have a coefficient for each term. So I have 7 for the linear, -6 for the constant, but where's the squared?
0.
Alright, so I'm going to actually go back. Now you can write it down with me, okay? I'm going to erase these numbers.
You always gotta write it down wrong first. No.
I didn't want you guys to have to erase. Sometimes I'll make a mistake and pretend I did on purpose. I'm like, oh, I was
It's
testing
like,
you guys.
actually, you're supposed to catch that.
That was your fault. I was seeing if you're paying attention and you weren't. And it only worked like the first time. After that, everyone's like, no, you just messed up. Yes.
You just forgot what you were saying.
Okay, hey, let's go to get some help here. Angela, do you remember how to do synthetic division? What do I do? Uh-huh. Okay. Now we'll add some -3. We'll just follow those same steps. 6, and then that gives us 0. Is that better?
Yes.
Yes, so now I can come here and say, alright, we knew we'd get a remainder of 0 because we already plugged it in and got 0 using the remainder theorem. But now we're more interested in our quotient here, because that quotient still has 2 roots inside of it. So now we've done 1, 2, 3. We're going to step 4, which is we are going to factor x squared minus x, or minus 2x minus 3. And I'm going to give you guys a 30-second head start. I want you to factor that because you need to be able to factor trinomials like that. So if it helps, make that little x and say, hey, what numbers multiply to this number, add to this number. Check with your neighbor. You got 30 seconds. Go. Alright guys, so we're saying what numbers multiply to -3 and add to -2, and what do you guys say those numbers are? Jade said 1 and -3, let's check that. Is 1 times -3 -3? Yes, is 1 minus 3 -2? Yes, so when I put this in parentheses, I got x plus 1 and x minus 3. That's how you factor. Raise your hand if you factored that on your own. Not nearly enough. Okay, so you got maybe a third of the class. Remember, if you're struggling with factoring, I put that whole factoring supplemental unit at the bottom. You can watch some videos, get some practice there. Okay, but then what does this tell me my x-intercept is here? -1 and +3. What did we get at the beginning? Our root was -2. So if I wanted to make a list of all of my roots or all my x-intercepts, I have -2, -1, and 3. Okay, now, is this tough? Yeah, this is kind of hard stuff. We've got a lot of steps here, a lot of new skills. This is like your level 4. If you want to be able to get an A in the class, this is the kind of stuff you need to be able to do for the standard, okay? Awesome. Now, let me show you one more skill you need to have, which is writing the equations based off the graph, which is actually going to be a whole lot easier than what you might think. Okay? So, before I do though, any questions on this? Okay, well then let's go on. There's one more at the bottom. I'm going to let you guys work on that as an extra practice. We're just going to jump straight into writing the equations of a graph. Okay, so guys, on this one, it's a little backwards from what you've been doing. Here's the graph, and now you need to write an equation. Well, if you think about what we did before, we did a lot of work to get it into factored form, and then once it was factored, we could find the roots. Now, in this case, we know what the x-intercepts are, just looking at this graph. Let's go to Antonio. What are my x-intercepts here, Antonio?
2 and
is it those? Is it bouncing or crossing? Crossing. What does that tell you? Not even. There you go. If the multiplicities are even, that's where they bounce. Okay, so let's come over here. So I know I have roots at -3, -1, and 2. The question is, how would I put that into parentheses? What we saw from earlier is we do the opposite. So if I see -3, what would that look like in parentheses? X plus 3. What about -1? What would that look like? X plus 1. And then with the 2? And guess what? That's your equation in intercept form. Isn't that great? Now, this does say it wants it in standard form. So, is this standard form? No, that's intercept form. What would I need to do to get it into standard form? You're going to multiply it all out. I'm going to show you one example where I multiply it all out, but from there you should be able to do it, okay? Okay, let's do that. Multiplying it all out. What does that mean I have to do with these? I'm going to do this just one at a time. So I'll take these two. We're going to multiply it out. So x times x, x times 1, 3 times x, 3 times 1. That's going to give me x squared plus 1x plus 3x plus 3, which if I combine like terms, that's x squared plus 4x plus 3. Okay, that was step 1. Are we all multiplied out yet? The answer is no. By the way, I should have mentioned this earlier. Your test on Friday, you get to use your notes for it. So right now you should be taking some pretty good notes. Alright, when I come over to this one, I'm going to distribute the x to all of these, and then -2 gets distributed to all of these. And guys, what did we just make?
A double crab claw.
Called the Megazord lobster claw.
Megazord.
There we go. Alright, let's write out what is that equation going to be? Well, when I do x times x squared, I get x cubed. X times 4x, I get 4x squared. X times 3 is 3x. Then let's distribute the -2. -2x squared minus 8x minus 6. So I'm kind of putting it in rows there. And I like that because then the like terms are diagonal from each other. These are the ones that I can combine. So there's only one x cubed, I'll keep that there. 4 minus 2 is 2x squared. -8 plus 3 is -5. And then there's just -6. So that is the equation of that polynomial based off its graph. This is a level 3 skill. Okay, so your level 3 question will be like, hey, here's a graph. What's the equation? Can you do that? The big thing is looking at the x-intercept, determining if it bounces or crosses. The other thing is, does the x cubed match the shape of the x cubed here? Yes. We're going to do 2 more, but we're going to go a little bit faster. I'm not going to multiply them all out, okay? Any questions on this before we go to the next one? Oh, was I pushing it?
We use decimals on the test?
Yep.
What? That's all the answers.
Maybe. If people would do the answers, they still want to do it. So, I expect you to still be honest with it and use Desmos to check your work, not to do your work for
I
you.
use decimals to find the answer.
Okay, let's go to Madison. What are my x-intercepts for this polynomial here?
It's -3, 0, and then 2.
Yes. Now, at -3 it's crossing, at 0 it's crossing. What is it doing at 2? What does that tell you about the equation we're going to write? How do we make it bounce at an x-intercept? Square it. So, let's put this. How do I put -3? I'm going to write this as -3 the sign so it's x plus 3. What about just a 0? What will it look like if there's a 0 as an x-intercept? Gonna wait for it. You guys know this one.
X.
It's just a plain old x. Because I'm thinking, what do I plug into x to turn it into 0? 0, so it's an x. Last week, too, we're going to change the sign so it's x minus 2. But how do we make it bounce? Put a square. And there you go. Isn't that a little bit easier than you thought it was going to be?
The X is in the middle. You gotta move it outside.
And yeah, so I usually put an x in front, but it doesn't matter. How would you check your work?
It matters to Desmos.
Desmos. Your graph should match, okay? Last one here. I'm going to give you guys a 30-second head start on this. I want you to figure out the x-intercepts, whether it bounces or crosses, and start putting it in a parenthesis. So everyone, last one, give it a good effort.
What if I put like to the power of 4? Would it still be correct? To make it bounce?
The graph would not match exactly. It would be probably more extreme in the mins and maxes. But your x-intercepts would.
Would be like almost there, but not quite.
It would be basically just stretched out.
I'm like 16 power.
Okay, Jaron, what are your x-intercepts here? Okay, so let's rewrite that out. We got -1, 0, 3. What is it doing at each of those, guys? Hey, stay with me. Guys, it's like, still have like 5 minutes. Calm down.
Oh, what?
What's the multiplicity here?
3. Nope.
This is
One.
crossing.
1.
This one is bouncing.
It's 3.
Okay, now when I put this into parentheses, guys, the -1, we know that's x plus 1. The 0, what is 0? Just an x, good job. But to make it bounce, I'm going to square it.
Put it in the front, am I doing this over?
It's fine, Mindy. Now, guess what? If I were to take this thing and write it in Desmos, it would be wrong. You know why it'd be wrong? There's just one teeny thing it's missing.
What?
Well, look at the shape of this.
Oh, it needs to add up to be odd.
Well, so it needs to be odd, which
Or 5.
we're okay with
Negative
it.
X.
What is that? You need a negative. See how it's a flipped S?
Yeah.
How do you make it flip?
You put a
You just
negative.
Boom, and
You
you're done.
put your X in front and then you put a negative in front of the X.
Okay, now your homework. Can I borrow this real quick? If you look at the same assignment I gave you last time, the first 12 problems was graphing. You should have been able to do that, but
Yeah.
finish that. And then the next 4 are from a graph, writing the equation and analyzing it, okay?
Yeah.
So look at the homework. Come back with questions. We'll review on Wednesday, and then we'll take your test on Friday.
Is it like a paper test?
It'll be an online test.
Is it like a paper test?
It'll be just like the quiz.